Okay, so we are going to spend today doing a little bit of review from things that we've done in the past and combining it with our last hypothesis test, so combining it with some new information. So I wanted to kind of take a step back first and look at some things that we've done in the past with regards to bivariate data. The FRAPI we just talked about dealt with qualitative data, where you had to make a graphical display that showed qualitative graphs. Now we're going to kind of change gears a little bit, and we're going to look at a bivariate situation. When I say the word bivariate, remind me what kind of words come to mind. Two variables. What kind of variables are they? Quantitative, they're measurable, okay? What kind of graphical displays do we do with bivariate data? Scatter plots? What else? Another kind of plot? Residual plot. So we're going to look at all of that again. We're going to look at how do I come up with the line of best fit? What does it mean to describe a scatter plot? What kind of keywords am I looking for? So I'm going to have you start. We are going to make the graphical displays in the back of your sheet. You do have this data, this problem in front of you. On the back, and I do have rulers up here if you wanted to use a ruler, I'd like for you to make as accurate and detailed as you can on half of this, because we're going to do both plots on the back, so don't take up the whole back. But I'd like for you to, on the top half, to create a scatter plot. You can use your calculator to help you. I also want you to find the line of best fit. So I really want you to answer questions 1 through 5 right now on this sheet. I'm going to pause the recording, and then we'll go from there, okay? So use your calculator 1 through 5, create a graphical display or a scatter plot, find the correlation, and then we'll go over how to do all of that together in just a minute. So here's a question I have for you. As you're entering in the data, when you look at the graphical, or when you look at the table that was given to you up here, you have student number, anxiety level, and math test. Which of the two variables I'm worried about? The student number doesn't really mean anything, does it? I mean, it's matched by that student number. You can kind of think about this as a matched pairs test if you wanted to. They're matched. Is there a difference between? But you really are trying to show that one is associated with the other. So it's a little bit different. But the student number just implies that you really can't sort these lists. Okay, they go together. So when you enter them into your list in your calculator, you can just skip over the first column. You don't need the student number. We are really worried about the anxiety level and the score on the math test. We're trying to see if we're more anxious, is our score going to be lower or higher on the test? Is there some sort of relationship there? So that's the columns that you put into your calculator. Those are the variables that should be associated. So in addition to just the scatter plot, you're going to need to find the correlation. Do you want to remind us how we do that? If I have these values in the calculator, I go to where? LinReg. So if I go to Stat, Calc, we have two LinReg options. The first one is going to put the slope first, which is fine, but in the formula sheet that you use on your formula sheet, and really the most accepted statistical equation for linear regression is down here at option 8, where the slope is written second and the y-intercept is written first. So that's the one that I will tend to use. We are going from list 1 to list 2, and we will calculate it. Now, as a reminder, on the AP exam, I will have to reset the memory of everyone's calculator. And when I reset the memory, the default means the correlation will not show up. I don't know if I've reset the memory here. Let me see what happens. Oh, sugar. It doesn't show up. So what do I need to do? Who can remember? Actually, you can go to mode, and you can, because we all have updated operating systems on our calculators. And if you go to stat diagnostics, we're going to turn them on. Okay? So just make sure that that's turned on. Then you can go ahead and go back to stat calc and do our linear regression. And hopefully at this point, it will calculate not only the line of best fit, but it will also calculate the correlation in R squared. So go ahead and put those things in. If you would also make sure to put context into your equation. That's important. All right, so we have our correlation. I'm going to quickly just show you on the calculator how to make a scatter plot. Matthew, would you turn the lights out for me real quick? I have to sit in the back of the computer because my smartboard's acting funky. But I walked by and it looked like just about all of us were doing this. If you go to stat plot, we're going to turn it on. Make sure you realize that the first option is your scatter plot. This last option is a normal probability plot, which we will look at in a minute as well. But for now, we're going to do a stat plot from L1 to L2. That is correct. We will go ahead and make sure that we have nothing in our y equals. I don't. And we'll zoom stat. And we should see oh, I didn't zoom stat. I hit something wrong. Zoom stat. There we go. Let's try again. There's our data. To me, it doesn't look super linear. Would you agree with that? Not super linear. And when I actually did plug in and I did my regression, I can plug that equation right on. And I would like for you to sketch the line of best fit on it as well. I believe it's what, 91 point something? What was it? You guys, what was your equation? What was the y-intercept? 91.66 minus 4.49x, is that correct? And if I calculate, or if I put that right on top, you'll see that there's your line of best fit. The y-intercept is at about 91. So looking at your scale on the y-axis that you're graphing, you want to hit it right at 91 with a slope of negative 4 point whatever. Let's write down what that means. So I do have a y-intercept of 91.66. I do have a slope of negative 4.49. Can we talk about what that means in context? Remember how we had to interpret these values in context back in the day? What does that mean exactly? What does the y-intercept mean in context here? Which value is our x? Which value is our y? Anxiety level is x. Math test would be y. So a y-intercept of 91.66 means what? Samantha? Yeah. I predict, because remember our line of best fit is a line of prediction. I predict if I have a 0 on the anxiety scale, I will get a score of 91.66 on my math test. That's what that means in context. How about the slope in context? Remember what slope is? Slope is the change in y over the change in x. The change in y means, so this is, we can put this over 1 if that helps you. X is your anxiety, and this would be the score. So for every 1 point, go ahead, Katie. Exactly. For every 1 point increase on the anxiety level scale, I'm going to decrease my score on the math test by about 4.5 points. Now, is this perfect? Of course not. Remember that if you look at the actual calculator, the line of best fit, I can't even tell how linear it really is. So we need to ask ourselves some questions. How linear is this data? When it asks you to describe, I believe that's the next question. Let's go ahead and look at the next question 2. What was question 2? Find the correlation. What was the correlation? I'm sorry, question 2. Let's do question 2 too. Does there appear to be an association between anxiety level and test score? Describe what you see in the scatter plot. How do I describe bivariate data? There's 3 things you need to say. Do you remember what it is? Strength, direction, shape. So strength, direction, and shape. Okay? What kind of strength? The correlation was negative 0.5 maybe? I forget. 525? So that is a measure of strength and a measure of direction. So let's use both of those words. Using a correlation of negative 5.25, I have strength and direction. Help me out. I would say weak as a strength, wouldn't you? It's definitely not super strong. So I would say weak, negative. Well, scattered's not a shape. Shape means that it can't be weak scattered because it is pretty scattered. What is it weakly measuring? It's weakly linear. Wouldn't you agree? So that's what I want you to say. I agree. It looks kind of scattered to me too, but scattered's not a shape. So when I talk about shape, I mean quadratic, curved, straight, linear. Those are things when you say bivariate data that we're looking at. Okay. So we're going to say that it's weak, positive. I'm a liar. It's weak and negative. Definitely negative. Thank you. Weak, negative, and linear. Okay? Be very careful with putting LYs on these words, and I mean this. 2 years ago, if you wrote weakly linear, the LY meant that you weren't sure whether it was linear or not. Not the weakly was not a description of strength. So be very careful. Don't put LYs on these words. Literally, it was a difference between an E and a P. Silly, an LY, but it did. Okay? So when you're describing bivariate data, no LYs, no adjectives. Okay? Or is it adverb? I don't know. Is it adverb? What's the LY? LY is adjective, right? Okay, yeah. Anyway, English teacher, I am not. Okay. What does the correlation indicate in question 3? The strength and direction, right? Right. How about R squared? What is R squared? It's a percentage, so tell me what it is as a percent. 27.6% of. Now let's see if we remember the sentence that we need to write. Matthew, you got it? Read it. Okay, so I'm going to write down what you wrote, and then I'm going to replace a word. So 27.6 of the variability in Y that can be explained, is explained, we'll say, is explained by X. And I'm going to use the word of here. But same idea, okay? So it's a percentage, and remember that data has variability in it. And this is an actual measure of the variability in one variable that's explained by another. Now, instead of using Y and X, because you won't get credit for that interpretation, what do I actually have to put in here? The context. So what variable should I put in for Y? Math score. You could put student performance there if you wanted to, okay? Is explained by anxiety level. So not a lot, right? The variability is not really explained real well. To me, if I'm just looking at questions 1 through 4 right now, do I have a real positive thought that the data is linear? Not super super positive. What's another thing, and what's we look at the scatter plot, we look at the correlation, and what's the third piece that we want to look at to answer the question, is the data linear? The residual plot, okay, and that's really going to give us a bigger context clue. So let's remind ourselves how to create a residual plot. And I do want you to sketch it on the back, if you would. So if we go to our calculator, remember the steps. We have already done the regression line. And the calculator uses the most recent regression that you've done on the calculator. So if you forget that step, if you don't go, excuse me, to Stat Calc LinReg, it won't work. Remember what a residual is. It's the difference between this observed value, and then this is the prediction line up here. So it's the difference between the observed and the predicted. This has a very large residual here, wouldn't you agree? Whereas a small residual would be here, because this point is on the line. Small residual, large residual, observed minus predicted. If I go to Stat and back to Edit and go up to List 3, okay, the calculator will automatically calculate the residuals. We did them by hand back in October whenever we did residuals, but you can do them on the calculator. If you go here, and again, you've already calculated the line of best fit. If you go to second Stat, which is List, option, I believe it's 8, there we go, Resid, stands for the residual. So again, second Stat, which is your list, go to residuals, and as long as you have the L3 highlighted, it'll say, oh, you want me to put residuals in there? And you want to say, you betcha. And there they are. Okay? How do I have the calculator draw a residual plot? It's a type of scatter plot, so I'm going to use the same thing. So when I go to Stat Plot, rather than from L1 to L2, what am I going to be choosing? L1 to L3. I want to graph the X values and the residuals. So L1 to L3, we'll zoom Stat again, so we get a better picture. And here, Boris, is where you'll see some negative values and some positive values. Here's our residual plot. So if you would kindly, sorry, sweetie, put this graph also on the back so you can see it. Up to L3. And stop. And you're going to go here. Option 8. And hit enter. Okay? Mm-hmm. All right, so I've got my residual plot. What am I looking for in my residual plot? A scatter. I want no pattern whatsoever. And that's what actually happens. I have no pattern. That's great. I don't see a pattern here. There's not a curve or it's not linear. It's scattered, which is good. Well, what is that? That kind of gives me some conflicting information, though, doesn't it? Because the residual plot shows no pattern, the scatter plot wasn't really strongly linear, and the correlation wasn't strong. So I don't have enough information right now to say, yes, I think it's linear. Would you agree with that? The scatter plot was not real strong, correlation wasn't real strong, but that's a pretty good scatter. So I have one thing saying maybe linear, one thing saying definitely linear. Well, there is a hypothesis test designed just for this, and that's what we're going to look at. Okay? So once you've got your scatter or your residual plot down, here's where you're going to need to get out another piece of paper, and we're going to actually look at the residual. We're going to look at the hypothesis test for this. I'm just going to fill the rest of question all the way to question 8, because we have answered all of these questions except for question 9. So I'm just going to fill these out. Make sure in question 5 you are putting it in context. Is it 4.49? I think it was. Okay, so just kind of formalizing what we've already said up to this point. We are now going to answer question 9. Does this prove, the word prove, that anxiety interferes with student performance? I don't think that this alone will prove anything, but a hypothesis test will. So what we need to do is we need to look at this from a hypothesis test point of view. But let's keep this context of the anxiety level and math score, and let's actually look at from a hypothesis standpoint. Now, we are also going to look at something that what I have highlighted here called a computer printout. And it is something that you will see and you will be using in your homework. AP asks us not to necessarily use the software. They can't force us to buy expensive software, but they can look at printouts from software and have us interpret it. If you notice on this printout, we do have the R squared. How would I go if I knew R squared? Is it possible to find the correlation? What would I do? Move the decimal point and square root it. Perfect. Something we need to talk about is degrees of freedom, and we'll talk about that in just a minute. We have some numbers down here that look awfully familiar, don't they? So these are things that we need to make sure we know. I know you don't have this printed, but they are on School Fusion, so if you wanted to be able to look at those. But this number here is, in fact, your y-intercept, and this number here is, in fact, your slope. Notice where they are in the computer printout, underneath the coefficient column, next to the constant. Well, that makes sense that it's the constant, right? It's the constant, so that would be your slope. And then with your anxiety level is your slope there. I'm sorry, yeah, y-intercept and slope. We had the two plots. Those are just kind of there for you to compare yours to, but they look pretty much like what we created on the calculator. Now, for a hypothesis test, when you have two quantitative variables that you are measuring, we are going to do what's called a linear regression t-test. So it still is, in fact, a t-test. We abbreviate it as a LinRegTTest. There is no such thing as a LinRegTTest on your calculator. So this is one that you won't be able to necessarily check, okay? So know that ahead of time. What is kind of nice is that these hypotheses are really what you'll say every time. And let's see if we can't break it down and why it makes sense a little bit. What does B stand for? This B. Not the null. Well, that is the null. It's part of the null, but there it's in both the null and the alternative. What does this number stand for? The slope. This is the slope of the sample slope. Whenever we write the hypotheses, we're always talking about a population parameter. So we're always going to use the parameter values. So that's just why it's a capital B. That's the only reason, okay? It's a beta, a B with a little tail. There is an association between anxiety and test score. So you want to make sure you put it in context. We'll say student performance rather than test score, because it does say student performance in the problem, okay? Okay, so there is no association is always going to be your null between your two variables. There is an association between the two variables is going to be your alternative hypotheses. What do you notice about the not equal to? What does that imply? What does that tell me? Two-tailed. I'm still doing a t-test, so I'm still using a test statistic that's a t-value. I will still use t-CDF to be able to find the probability of that. It is, in fact, two-tailed. No association. Okay? There are, in fact, 4 conditions, almost all of which we do anyway. There's only one that's new. Okay, so the 4 conditions, and by the way, I've never really seen, well, I shouldn't say that. It could happen this year. I hate to say never because they always throw something on there. So the first one's called the straight enough condition. You've already graphed a scatter plot, haven't you? Does it look like it's linear? I'm not sure it kind of passes this one. This one's like could be linear, right? I don't know. But you're going to graph a scatter plot. We've already done that. No patterned residuals. Didn't we just do a residual plot too? Don't we really do the 2 checked conditions when we're talking about bivariate data anyway? We do a scatter plot and a residual plot anyway, right? So those aren't really new. I mean, isn't that in every single condition, representative sample? So that's something that happens no matter what. The unusual one is that we have to do this. We need to graph a plot of some kind of the residuals. And we have to show that the residuals are relatively normal. This says a histogram. That will work. What's the other option to show whether it's normal? Normal probability plot, which is that last option. And so either one of those is okay here. But that option 3, that condition 3 there, is the one that's I wouldn't have thought to do. So get your calculator back out. Let's graph. I'm going to do both. You don't need to. You can pick one or the other. But let's look at the residuals. Where are the residuals again? It doesn't want to move over there, sorry. They're in L3, right? I go to Stat Edit. They're still over here in L3. I just want to do a plot of just those. I don't need this line of best fit on there anymore. I go to my stat plot. I'm going to start with the histogram just to see. Sometimes the histograms are funky in this. Remember, they don't really look right sometimes. Let's just graph it, see what it looks like. I need to make sure we're doing L3, and we'll zoom stat. And let's just see what it looks like, okay? I'm looking for it to be relatively normal, which means I'm looking for unimodal and symmetric, right? What kind of graph do we have? Oh, helped if I actually did it right. Sorry about that. Zoom 9. Not too bad, right? It's fairly unimodal and symmetric. If I wanted to be really sure, I could do a normal probability plot instead. I think those tend to be a little bit better on the calculator to show normality. So I'll do that one. And again, it's L3. Remember, the normal probability plot is the last stat plot. And we'll go to zoom stat. I think that's pretty straight. Wouldn't you agree? So I think that the residuals are pretty normal. So I think we've met the conditions to do the test. Okay? Any questions so far? Y'all are being real quiet and it's kind of freaking me out. I don't get it. It's a lot of information at once. A lot of review. I get it. The residuals. There should be no pattern. When you did a residual plot, when we originally did the plot, it should be no pattern, scattered. And it was. Remember, if we looked at this residual plot, had no pattern here. Okay. Step 3. Test statistic and p-value are always going to be the third condition, or the third step to a hypothesis test. This is the formula, okay, in case you need to know it. Unfortunately, it's not on your formula sheet, I don't think. Isn't a t-score normally this? Right? Isn't that normally the statistic minus the parameter divided by the standard error, right? Well, that's really what's happening. It's just that the test statistic this time is a slope. So it's the slope minus the parameter, which should be 0, divided by the standard error. So it's really still a test statistic. It's still the t. It's just written a little differently. What was our slope? Negative 4.49 minus 0 divided by, this is a number that's going to be weird, okay? It's going to be provided for you. If we go to our computer printout, it's going to be on there. Well, let me show you where it is, okay? So that's what I want you. Oftentimes you're given this information as a computer printout, and here it is. This number right here, 1.551, is the standard error of the slope, okay? This number right here. It's the standard error of B1, okay? So that's what you would put down, 1.551 in your denominator. Tell me what your test statistic is. It should be negative. So 1.551 goes in my denominator. Write this down, okay? It's negative 2 point something. 2.89, okay? I agree. So how do I use that to come up with a p-value? We'll draw it. Okay, we'll draw it. Let's start there. Remember, the 0 goes in the middle. Negative 2.89 is here. What did my alternative hypothesis say to do? True tail, which means I'm going to put a positive 2.89 over here, and I'm going to look at both tails. Would you agree? Okay, both. It's a t-test, so I'm still going to use a t-CDF. Which tailed, oh, by the way, since it's two-tailed, shouldn't I multiply it by 2? So I'll do that in the beginning. Which tail do you want to use? I don't care. Positive ones. For some reason, they tend to be easier for people to understand. But we'll use a positive. That's fine. So my left-hand side of that right tail is positive 2.89. All the way to the right would be positive, some number off to the left. What about degree of freedom? Anyone catch what it was? I wrote it on the last slide. It's n minus 2 because it's bivariate data. So you're subtracting 1 from each of the variables. That's really why you're doing it. So n minus 2, in the data we had 24 data values. So our degree of freedom will in fact be 22. Okay? N is not the number of categories like it was with chi-squared. It is the actual number of data values again. So it is n minus 2. Tell me what you get. What's your p-value? I did too. Really quickly, before we write our conclusion, let's look at the computer printout and see if you notice these two numbers anywhere. I bet we will see them. There's your test statistic. There's your p-value. The computer printout actually gives you everything you need, okay? So this number is your test statistic. This number is your p-value. Oftentimes on an AP exam, they'll give you a printout and ask you to give me a conclusion. You need to know where to look to find the p-value. You can look at that p-value and say, what, right now? Reject that sucker, right? Reject the null, which means what? Based on this computer printout and this p-value, there is an association between test score and anxiety level. That's what that says. Okay, so that's your conclusion. Make sure you show linkage. Compare that that p-value to 0.05. So I do see that this is in fact less than 0.05. We will reject the null, and we will say we have evidence to suggest that there is an association between anxiety level and student performance. Okay. But we had to come up with a p-value to prove it. The p-value had to be small. The probability that our sample happened, given that our null hypothesis was true, had to be very small. And it was small enough. Quite small, actually. Okay? Now, last thing that we need to talk about today is the corresponding confidence interval that would go with this. This is the formula that is the confidence interval. Okay? In your homework tonight, you will have several hypotheses tests that you have computer printouts from. I'm not expecting you to do them all by hand. Use the numbers that come on the computer printout. That's fine. Okay? You can use them. Question? You won't have to do, you will still have to do all the steps, but you don't have to do any of the calculations. You can just say the test statistic is, the p-value is, because you can get it from the printout. Okay? What is my slope here again? Because remember, this means slope, negative 4.49. We'll come back to this t star. The standard error was 1.551, right? What's t star? Do you remember? Okay, so I have 95% confidence, so I'm going to go ahead and do my 95 in the middle. Remember, t star is this number. We want to go to the left. What is one of the tails going to be? 2.5% or 0.025, which means to find t star, inverse t, what goes in it? 0.975. My degree of freedom is 22. You should get this number. Double check that you do. Okay. Double check that you do. So take a minute. Find the confidence interval and let's interpret it. What does it mean? So go ahead and find it and then let's interpret it. Okay, I agree. 0 is not in the interval. What does that mean? There is a difference. Oh, no, there's a difference. We're not looking at a difference. We're looking at a relationship. The slope is not 0, right? So that means there is an association, okay, between the two quantitative variables. So that's good. So 0 is not captured. Therefore, what? What can we say about these numbers? What numbers are these again? Give me context. They're slopes, right? Didn't we start with a slope here, and we added numbers to either side of it? So these are slopes. So if it helps you, put them over 1, and we can say what? As we interpret slope, we're going to do the same thing. We're 95% confident that as what increases? As the anxiety level increases by 1, what happens? The math score or student performance, however you want to say it, decreases. Can't even write the word. Here we go. Try again. Decreases by between 1.27 and 7.7 points. Do you agree with that? That's how much it's decreasing by, because those numbers are slopes. So we're going to interpret them just like we interpreted the slope early on. Now that is a lot of information today, okay? A lot of it's stuff that we have already done, but it's been a while, okay? So it's not a bad idea to go back through it. Let me go ahead and tell you what your homework is going to be. It is going to be, oh, by the way, I had another problem, but we're not going to do it, okay? Your homework is to read chapter 26. I'm not going to have you do the just checking. I don't want you copying what it says, but I think it's valuable to actually read the chapter. And I want you to do the problems. I think I already texted it to you. 11 through 14, which are all hypothesis tests with the computer printout. And then 30 is the confidence interval question. Okay? So those are going to be your homework. I do want to see the 4 steps in your hypotheses, but you don't have to show calculations. You can just just write down what the information is, okay, on the test. So it's not as much as it seems. Fair enough? All right, if you borrowed a ruler, if you would kindly put it back for me.